One of the uses of the rectangular model is to provide meaning to multiplications beyond the times tables. Using some examples, let's see how we work on this. Let's suppose that we want to multiply 13 by 7. We can represent this multiplication using a rectangle formed by 13 columns and 7 rows and ask how many small squares there are. Counting them one by one would take too long, so we can break down 13 into 11 plus 2 in order to break the rectangle into two parts that are easier to calculate. We know that 11 times 7 is 77 and 2 times 7 is 14. So in total we have 77 plus 14, in other words 91 small squares. But we can also break down 13 into 10 plus 3, for example, which means breaking down the tens and units. We have 10 times 7 equals 70 and 3 times 7 equals 21. And we immediately add 70 to 21, 91. Let's look at another example. 32 times 6. Drawing the squares is not essential, we can leave them out. Now we can break down 32 into 10, 10, 10 and 2. So we get 10 times 6 equals 60, and we have it 3 times. And 2 times 6 equals 12. In total, 60 plus 60 plus 60 plus 12, which equals 192. But we can also do it more quickly by breaking down 32 into 30 plus 2. As 3 times 6 equals 18, then 30 times 6 equals 180, and 180 plus 12 equals 192. And if we would like to multiply 24 by 26, we can break down 24 and 26 and do the corresponding multiplications. Given that 2 times 2 equals 4, then 20 times 2 equals 40, and 20 times 20 equals 400. Then 20 times 4 equals 80, 6 times 20 equals 120, and 6 times 4 equals 24. Now we only need to add, and we can do it by rows, by columns, or freely, as we wish. In total, we have 624. Ultimately, we have seen that the rectangular model allows us to carry out multiplications in a transparent way, which is flexible for both the breaking down we choose and the partial additions we do.